So hello, everyone. Thanks for tuning in. This is another exciting learning lab, and I have a special guest with me today. It is none other than Julia Silge. She's the author of Tidytext. She's also a data scientist with Rstudio, and she's going to be joining me to talk about workflow sets today. So workflow sets, it's an awesome package. And we're going to be focused on experimenting with many machine learning models. And we've got an interesting business case today where we're going to be looking at the compensation of various CEOs. And we're going to show how you can make a modeling project out of it, and how this also maybe relate to like certain HR types of problems where you have employee data, you also have resume characteristics and those sorts of things. And you want to be able to build a model that actually calculates how much compensation a potential new hire should get. So with that said, this is going to be an exciting learning lab. I'm really interested in getting to know Julia even more. I've been a big fan for a while now. And Julia, is there anything that you want to say to get this thing kicked off?
Well, I'm so glad to be here. Thank you so much for having me, Matt. It's been so interesting to see the like all these different topics you've been covering and all the ways you've been sharing knowledge in your learning lab. So I'm really glad to be here. Thanks for having me.
Well, thank you for being here. It's a pleasure. Believe me, it's our pleasure. All right, so let's get this thing kicked off. So to get things started, our goal for today is going to be to build an application that makes it easy for people to analyze and evaluate some of these different CEOs out there. We're going to be looking at compensation modeling, and we're going to be using the main tool today, or the focus is going to be workflow sets. It's a new R package that has just recently been added to the Tidymodels ecosystem, and we'll talk a lot more about that as we go through today. If you are not familiar, you are part of today a learning lab. This is learning lab number 55, and I can't believe it. We've got 54 other ones. And what we do is we put these into a program called Learning Labs Pro. So if you want to see any of the past episodes that we've done and get access to the code that we've previously written and gone through on each of these labs, you're more than welcome to join us. And there's some good reasons why you may want to do that. But first, I'm going to put into the chat here a link if you guys want to check out Learning Labs Pro while I'm talking about it. So there's all sorts of different topics that we talk about, and probably the coolest thing is that we've started to do some series. So we've been working on Tidymodels here recently. It's such an awesome ecosystem. It's growing, and we now have 1, 2, 3, 4, 5, and this is the 6th different lab that we have focusing on the Tidymodels ecosystem. And we have many other series just like this. Things touching on topics like machine learning, touching on topics like SQL and ML ops, which is a kind of a more advanced topic, and so on. So definitely check those out. Probably one of the coolest things though about becoming an LL Pro member is when you join, you get access to a bunch of different bonuses. So every lab I try to give a bonus, and the lab today, we've got this shiny application that integrates a bunch of cool technology, workflow sets. It integrates several different data sources. It integrates some kind of cool techniques inside of Shiny that I'll showcase here in a bit. But you also have several other different applications. Lab 52, we did a Shiny customer retention app with stacks. Lab 50, we did a Shiny hierarchical forecaster with like GBM. And Lab 51, we did a lone default scorer with Torch. And labs 49 and 48, we did a customer segmentation app and an NLP token automation app. So very cool stuff. If you're interested in getting access to any of that, check out Learning Labs Pro. Okay, Julia, I want to switch gears. I want to talk with you about your experiences. I want to talk with you about some of the things that you're involved in. So I did a little bit of research before having you on here, and I hope that's okay. But I want to just kind of chat with you a little bit about your background and kind of where you've come from. So who is Julia Silge?
Yeah. Well, so my academic background is in physics and astronomy. I got my PhD in astrophysics back in the day, and I taught as a research for a while, and then kind of had a little bit of like a winding career path after I left academia. I worked at uh, like tech startups that were kind of in the ed tech space, developing content, like educational content that was kind of a half coding, half content kind of job.
And was this always using R? Is that
No. At this point, I literally did not know that R existed. Like I had
Oh,
never.
wow.
At this point, like my first sort of coding experiences were well, I mean, my very first coding experiences, like back in high school, were, basic and whatnot. But my first like real coding experiences were all like C, and so compiled languages, and then it was more like front end kind of work, like interactive front end kind of work for a while. I don't have a ton of formal stats training. And I think that's part of why R and I didn't really cross paths for a long time. During my undergrad training, so I was a physics major as an undergrad, and I actually took zero statistics classes, like as an undergraduate. Like they had me take computer science classes, but not any statistics classes.
Right.
When I went in grad school, there were like some like domain specific kind of data analysis classes where they covered some stats content, but so, I'm old enough actually that but that there was really not strong machine learning content at the time, because at that time in physics and astronomy, people were not really using modern machine learning methods.
So you can, I guess it's safe to say that from a data science perspective, you were mainly really doing stuff in more kind of lower level languages like C, and your data science journey really didn't bring you to cross path with R until later, right?
Until much later.
Okay.
I did a lot of, so my computational background was diverse, I guess you would say. Like I did some embedded work because I was a observational astronomer. So I used the actual, did work on the actual telescopes and instruments. And so like I did some work on the like the software that would drive the actual instrument that would go on the back of the telescope and whatnot. So that was all C as well.
Wow.
At the time. That stuff might still be C. So today, I think like if I was 20 years younger than I am, I'm sure I would have learned Python in grad school. But I'm not, so I didn't. So I learned C. And so at the time, people were either, and I think this might still be true, like in grad school, people were either learning and using kind of pointy, clicky, expensive license software to analyze their astronomical data, like IDL and IRAF, which I'm not even sure if it's still around, or people were writing their own code, and which at the time was like Fortran and C. And so I kind of went in that bucket. And now I think there's people who still use IDL, and people are mostly writing Python today in physics and astronomy.
So walk me through then. How do you go from being an astronomer, from a background, and I'll say not necessarily data science, to getting to the point where you are today, because you're now working at Rstudio, like one of the premier data science organizations out there?
Yeah. So I was so I was working at that ed tech startup, and I had actually, like, kind of in this sort of path that I had taken, I had actually taken a couple of years off completely from the paid workforce when my kids were very small. I'm a mom. I have 3 kids. And when
and congratulations. I mean, that's especially in these times right now. It can be a
Yeah.
challenge.
Yeah. So when several of my kids were like babies, there were a couple of like I took a year off here and there, and when they were very small, but I was back in the like paid workforce doing like a physics and astronomy content / coding work. The particular place that I worked, I mean, to be honest, they had layoffs. They had layoffs, and they immediately hired me back as a contractor. But I was like, that sucked so much.
Yeah.
And I like my kids were getting bigger, and I started looking around and thinking like, what do I want to be doing? And like, what do I want to be doing at age, X and Y? Like as I think about like what's next for me in
You
life.
started looking at your career and seeing if there's, where you wanted to go with it, right? Is that?
Yeah, yes. And that was at about the time when more people with backgrounds, like the kind of degree that I had, were starting to get jobs in data science. And I started seeing people from like my cohort and younger, to be honest, getting jobs in data science. People from my cohort and older, when they got jobs in industry, they were getting jobs with titles, like they were getting jobs in finance as like quants. They were getting jobs in as just like straight software engineers. But people like kind of in my cohort and younger, when they were going to industry, they were getting jobs as data scientists. And so I'm like, tell me what it is that you're doing. And they're like, oh yeah, I write code to analyze data and make plots and write about the results, and I am thinking, wait a minute, that was my favorite part. that was my favorite part of what I did when I was doing research, like when I was dealing with real world messy data. Like that
Good.
was the part I liked the best. There's a job for that now. So when I experienced that layoff, I started to think about like what would it take for me to transition to that kind of career. So I was working as a contractor for the same company, but I wasn't really fully employed, and so I had a little bit of sort of give in my schedule. And I would say I took like 6 months, and I already had a PhD. So I was like, going back to school is not the right call for me. Right. But I took like 6 months, and I took basically every MOOC that exists.
Ooh, okay. So you use kind of the new and advancing educational platforms that are out there to get upskilled pretty quickly. That's great. That's great to hear.
And I was like, okay, obvious. I mean, I felt in my heart, like I was like, I can do this. I've done this before, but I'm like, oh, I don't know any of the right languages.
Well, let me ask you this. Can I just so what I'm really interested in now that you're talking about this, how do you go from kind of that career path and kind of and maybe doing like a little self-reflection of like, hey, where am I at now? Where do I want to be? How do you go from that to starting like to learn R, and then the Tidytext, and then eventually the Rstudio? I mean, I'm not sure how all that panned out, but how does that work?
Yeah. Well, so when I started realizing I need to like update some of these technical skills that I have. Like I have confidence in my like quantitative ability, right? But like I need to update some of these specific technical skills. I look around, what do I need to learn? I started with Python first. I'm like, okay, this is okay. There's like good things about it. And then I started learning. I was introduced to R, actually by the Johns Hopkins MOOCs. Actually, is what introduced me to R.
I took those. Yeah. Yep.
Literally had not heard of R before of those. Like just because of the particulars of my own academic path, like literally did not know existed before those. And I sort of quickly became introduced to like a Tidyverse approach to R, and then like a sort of Lispy, like functional programming approach to data analysis. And I was like, this is for me. Like, this is it. I love it. It's fantastic. I I love it. This is for me. And I, just because of kind of the background that I came from, that was much more appealing and in line with how I thought about data analysis than the more like object-oriented approach of Python,
Right.
which of course has good things about it, but I was like, oh, I'm not enjoying this. You know, like this is not fun for me.
Yeah.
Whereas the functional Lispy approach, I was like, I love it. It's perfect. It is for me. And so I was like, oh yes, let's do it. I like learn more and more. And
me coming from an Excel background, I mean, I kind of I identify with that as well. So what you felt with, coming from your background in mathematics and physics, and then having the object oriented versus the functional, for me it was, hey, object oriented, that's a pretty big leap from Excel, but functional, it's it's still a big leap, but it's manageable. That's how I felt, at least.
Yeah. The okay, so I eventually started building out projects that were initially intended to demonstrate how like my own ability to be hireable. Like that was the initial purpose of like, hey, I want to show I can use Python and R to analyze data in this way. I can use code, narrative, and data visualization to speak about how we answer questions with data. How can we kind of know the limits of what we can answer with any given data set?
Right.
How can we speak about things? So these were my goals with starting to put projects together. And as I thought about like, what do I want to, like, what kind of example data sets are out here that would be a good fit for me? I first kind of turned to local data sets. I live in Salt Lake City, Utah, and some of the first projects I did, like I just went to my local state's open data portal, and I used like example, just things that were like relevant locally, because I kind of thought I would probably be applying for jobs here in my city, right? And so I was like, hey, these can be projects that I can talk about with people about what I learned, that are relevant to my city. And then also, I just have always been a like lifelong reader. Like I love books and literature, and I found that you can get books that are in the public domain. You can get those texts. And so this was another example of like, hey, I can show that I can analyze text, and as I did that, I started to kind of bump up against some of these limits of what currently existed in R at the time. And that like you can do some of these things, but some of it doesn't have the nicest user interfaces to some of these functions. And it turned out that around a similar time, like David Robinson, another open source R developer, was having similar thoughts at some on the basis of some of these like blog posts that I was publishing. And we ended up collaborating.
Okay, cool. So you were doing blogging at that point in time too, and he was seeing that, and you were seeing his stuff. Okay, all right, it's making sense now. Good.
Yeah. So I didn't really set out to develop new software. I set out to transition my career and get a job and have projects to be able to demonstrate what I could do. But then I started being like, well, I could write a function that would make this nicer. And it's like, well, then I can put that function in a package. And David Robinson at the time was like, hey, do you want to collaborate to just actually make this a real thing? Do you want to make this a real thing?
Nice.
And I, coming from like the worlds I did, like say like C, Linux, the idea of open source, contributing to open source seemed
Was it
frankly terrifying.
yeah,
Like,
intimidating? Okay, so
yeah,
it was intimidating. Yeah, yep.
yeah, it's
I
like
hear that a lot. Yep.
that's like the world of like Linus Torvalds and like people you would never want to interact with, and you would like run screaming away from that world. Like contributing to open source is not something that is for me. And and so when I it was first like, oh hey, like let's make something, I was like, really? But I started taking steps into that world, and like I really
Well,
was. I
we're
was like,
glad you did. We're
well,
really glad you did.
well, thank you. That's very kind. I was like, I really was. I was like mentally prepared for like, all right, it's going to be awful, but
Yep.
I think I should give it a try. But it wasn't awful. It wasn't awful. In fact, it has been like, I mean, of course there's some things that suck sometimes, but like,
Mm-hmm.
but on, you know, overall it has been amazing, not awful. Like I have met amazing people. I have, you know, of course, had opportunities to share my work, to learn, to, and it has for sure like open career opportunities.
I'm just going to pull up Tidytext on GitHub. And
Yeah.
just while you're doing this, and I want to showcase for everyone just how impactful this project is. So 50,000 downloads a month, 1.4 million downloads total. And it's just this little package called Tidytext.
Yeah.
I will tell you what, that is impact right there. So if you guys, I'm putting it in the chat, you should definitely check out the Tidytext package. And we have actually, we have some resources too. Real quick though, before I jump to some of these resources, can you tell me just a little bit about you? So you've got several packages out there. You started the open source. Can you tell me what it's like now with your current role?
RStudio. Yeah. So that was very early kind of transitioning. But I'm just going to very briefly say that like my first job so I did interviewing, and my first job where my title was data scientist, I worked in the nonprofit sector, which was a really great place to start as a data scientist because so much data and so much like ability to make impact in that sector. And then I kind of transitioned. I worked for Stack Overflow for a while,
Mm-hmm.
and I've been at Rstudio for over a year now. And that has been an amazing opportunity to like work now full-time at Rstudio. So I would say before I maybe spent like 80% of my time analyzing data and maybe 20% of my time building tools, either tools that are open source for everyone or tools that were like internal to my company. And I do love building tools, actually all the way back, even to my like, you know, even to like through grad school and college. Like I've been really interested in how people like do things in the real world. And so I am really interested in process, in design, in just how people get their jobs done in the real world, in terms of like data and analysis. So I really like that bit. And I would say now that I work at Rstudio, it's kind of been switched the other way. So now I work on open source software as my day job, and like 80% of my time is spent on tool building, and maybe now like 20% of my time is spent analyzing data, either some of our own data or you know, open data to be able to use for teaching or demonstration purposes or anything like that.
Well, I was just going to interject real quickly. I think it's a huge value for you to have that practical real world experience. And then now being at Rstudio, you immediately are able to kind of say, you know, hey, this is how things are done in the real world. And you can kind of see and direct, I would imagine, some of the tool building. So that way it's in line with what practitioners are and how they plan to be using it, giving them that perspective. So I think that's really cool.
Yeah, I would not say I'm someone who has like super specialized interests in specific statistical methods, but I am someone who has this sort of broad interest in how people get data analysis done, you know? So it's
Right.
good to have people who have both of those kinds of interests, especially collaborating together on this kind of software. So
Well,
yeah, I work on Tidymodels. That's the team. So I know Max was here in one of your learning labs. So I work
he
with.
was. Yeah, we love Max. I mean, he's the, you know, the Tidymodels is one of the things that I've always, as soon as that started coming out, I was an immediate adopter. I I can't tell you how much I use that tool. It's in pretty much all of my code. I mean, model time, the whole time series
Yeah,
forecasting that I'm
yeah.
putting together is all that the stuff that you guys are working on right now. So it's super impactful to me and also my students. Yep.
Yeah. Yeah. So that's my day job now, is working on Tidymodels. So I work writing software. I work writing documentation. I work writing and demonstrating like training materials. So I am now officially a maintainer of one of the packages, along with my like
Which one?
packages
Which
from
one?
R sample. I'm the maintainer of
Oh,
R
okay.
sample.
I
Yeah.
love our sample.
Yeah. So if you've ever used, so a lot of you are probably familiar with Tidymodels, but if you're not, so if you ever have used Tidyverse and typed library Tidyverse, and you know, oh, this lets me have ggplot2 for data visualization, dplyr for manipulation, forecats for factor handling. Tidymodels is a similar thing where it's a meta package, and it has all these packages inside of it, where our sample, for example, is about data resampling, like testing, training, split, making bootstrap resamples, cross-validation resamples. Parsnip is about the models and how do we make and fit models. Recipes is about feature engineering. So it has all these packages, inside of it that are all part of the machine learning or modeling tune. Shockingly, is about tuning models. So we have all of these packages inside of it. And so during interactive model development, you can type library Tidymodels, but you can have these more modular pieces, which are more helpful. It's helpful to have them in modular pieces, either during model deployment or for model ops purposes. And it's also better for package development to have them as more modular pieces.
Right. Well, thank you so much, Julia. This has been a really awesome conversation on how your career has progressed. I wanted to really hit that home for our audience because I think it's really important to understand where we've come from and where and how we got to where we are now. And often, as with you and with me, and I'm sure most people, it's not always a straight line. We kind of have to figure things out and do a little self-reflection. So that was really an awesome perspective. I really thank you for that.
Thanks for sharing with me.
I have 3 books though. Would you mind if if we switch gears here and talk just really quickly? So the first book here, this is the first resource that I want to give everyone today. And this is compliments of obviously Julia and all the work that she's doing. The first one is the Tidytext mining book. So I'm putting it into the chat right now. If you guys want to learn about text mining, and I know this says tidy modeling. This should say text mining here with R. Julia has the Tidytext package along with David Robinson. And that's a free link to a free book. You can also purchase it, which I'm sure Julia would appreciate. But it's free and it's out there for everyone. So that's the first book. Is there anything that you want to say about this, Julia?
What I'd say, this book is great if you are getting started with text and you know your goal with text is exploratory data analysis for text. So you want to summarize, visualize, understand what is in the content of your text.
Yes, absolutely. Okay, the next one here is a new book that you guys, you and Max have been developing for a little bit. It's called Tidy Modeling with R. And actually, we're going to focus on today. There's a chapter 15 that you guys added on workflow sets. So that was one of the pieces that I used when developing this. So I'm putting the link into the chat. This is the Tidy Modeling with R, tmwr.org. And is there anything you want to say on this one, Julia?
So of the three you're sharing, this one is the least completed. So you can look for more to be coming soon on this one. This book is great. So if you are wanting to get started with tidy models, I would say start with tidymodels.org. So that is another link that Matt shared earlier. But if you're like, it is time for me to get a little more in the nitty gritty. It's time for me to, I have a question, or I want to learn more about how these things work. I don't want to just like get started. I want to understand a little more. Then I would say come here. I come here to this resource to learn a little more in depth.
Yeah, I would say the same thing. I've definitely spent some time in each of the different chapters, and this one is probably after you've kind of done the Hello World example. This is probably the next step or the couple steps after that. But I will tell you this: it's a great book, and I'm really happy that you guys put it together. The third book, and this is something. Would you mind telling me, because I know nothing about this book. This one was brand new to me when you told me about it. I did find that you're using text recipes in there, so yeah. I want to shout out to that package. I love that package.
Yeah,
it helps me so much with NLP for business problems. In fact, in Learning Lab 48, we had a special lab devoted to this package, because of how powerful it is for analyzing like product descriptions and in kind of like a tabular format. So for NLP.
Yeah. So if the first book was about EDA for text, this book is supervised modeling for text. So you're not in a situation where you're like, I need to summarize and visualize. What I need to do is I need to train a supervised machine learning model for text. It's divided. So this book is very close to complete. Like it's being published by CRC, and we are just in the like very final versions of like getting like LaTeX files to CRC. Like it is almost done, and it has 3 sections. The first section is about what are the steps that we use to take, let's call it raw text language, and how do we create features for machine learning from it? What steps are available to you, and what kind of impact do they often have on models, and how can you measure that impact? The second section is about how do we use let's call them traditional machine learning models. So these are things like naive Bayes, support vector machine, regularized regression. How do we use those kinds of models to train machine learning models for text? And this all uses tidy models. The last third of the book is how do we use deep learning models with text to do supervised machine learning with text. So it's like LSTM, CNNs, and things like that. And so that uses Keras together with tidy models. So together, Keras and tidy models together to train machine learning models for text.
That format is so effective. And I will tell you this, I'm going to parallel it to time series, because time series is like text is to you,
similar.
Time series is to me. So the time series course that I released follows almost an identical kind of progression, where you have the kind of like the beginning part of it is more of like the time series understanding, developing features, that sort of thing. And then the midsection is the machine learning, where you're using like XGBOOST and a lot of the supervised models. And then the last third is the deep learning, which is really powerful for doing time series analysis. So I will tell you this, your book, it sounds like it's going to be a major success, because the time series course has done really well, and that format just worked beautifully for it. So I think you've got a really good book design here.
Thank you. Yeah, we're excited. And our cover we just got, and so I can't wait to like put it in here. It turned out really beautiful. I'm really excited.
Oh, cool. Well, definitely let me know when it's ready, and I'll share that with everyone here too.
Nice.
The last thing I want to do before we move on to the meat of the actual learning lab, I want to I want to ask you, where can we get in touch with you? I've got a few links here. You've got Twitter, you've got a blog, you've got YouTube. I'm going to paste all of these right into the chat right now. If you guys want to learn more about Julia, can you tell me anything else that you want to touch on about how to get in touch with you or learning about what you're working on?
I think those are probably the best places to follow along, to keep in touch. Those are probably the best.
Excellent. Here, hold on one second. I think we were right here. Let me make sure I'm presenting from, I hit the wrong button, present from beginning. Here we go. Okay, well, thank you so much, Julia. I really appreciate that. You're welcome to stick around. We're now going to move on to the business problem. And I really do appreciate it. It's such a valuable thing, kind of hearing your story and how you got to be where you're at now, and also some of the cool things that you're working on. I really appreciate, and I think I speak for everyone. All of open source work that you're doing, it is so helpful. The books, the tools that you guys are working on at Tidymodels. I mean, it's just, we're indebted to you, I guess is what I'm saying.
Thank you. That is so kind.
So
I'm looking forward to seeing this walkthrough.
Okay, well, this is a cool walkthrough. It's a fun problem. So the business problem that we have today, we're going to be looking at an executive compensation model. So if you're interested in HR, if you're interested in any type of just analytics, even financial data, this will be a really good tutorial for you. So the compensation analysis. So employee compensation is something that a lot of, obviously companies have to go through. They have to understand and have a process for hiring employees and determining what to compensate them. And it doesn't matter if you're a CEO or if you're just, if you're just like you and me who are working in a company as an employee. We're all part of a kind of a grand scheme of things, and where you've got like a market out there where people are willing to pay certain rates and so on. So the key idea is that when developing a model, we need to, this is one of those situations where we really have to put a lot of thought into where we collect our data from and how to develop features and come up with different, recipes, and also figure out how to model it appropriately. So a couple ideas here for you. If you're modeling people, there's websites out there like Indeed for job postings that you can collect data, scrape data from. There's Forbes for CEOs. We can actually scrape data on, what these CEOs are being paid and some of the attributes about their companies. And particularly, I like looking at CEOs just because it's not, it's something that's interesting to me, understanding who's, leading what types of companies and how, what features are tied, that gives some sort of indication about their compensation. So we can look at performance metrics and employment factors. I do want to preface this though, before I get myself in trouble. This model is not intended to say, hey, one CEO is better than another. It's merely intended to showcase that we can model their compensation, but there may be many other factors to consider when a company decides to have a CEO and pay them what they're being paid. With that said, it's a really cool analysis. I think it's awesome because we'll get to work with stock data. We'll get to also work with employee compensation and talk a lot about performance. Okay, so I do have a quick demo before we jump into it. I've got this application up and running here, and this is the app that I just developed. It's a pretty cool app. Basically, it's got a data table in here. It's a Shiny app, and you can click on any row here, and what it's doing is it's pulling in the information from the model. So the model has predicted roughly a $34 million a year salary for this gentleman. Maybe you've heard of him. His name's Warren Buffett. He is the founder of a company called Berkshire Hathaway. And it shows that in 2008, because this data came from, is a little bit older, this data set came from 2008. And in 2008, he had a compensation of $100,000 per year. So this is, as you can see, it's in green. a big benefit to that company. They're getting a lot of value in having this CEO here. And I will also preface this, the data set being from 2008 was right after the financial recession. So if you can remember that far back, there was a big financial recession that took a while to come out of. And actually, this doesn't even show the full extent of it. It actually decreased even further from here. But these CEOs, many of the CEOs that were out there were cutting their payment structure with their companies in order to be able to help keep the company's cash flow positive. So that's what this Shiny app does. It allows us to analyze, different industries. We can type in things like semiconductors. So you can see, these are all the different CEOs from different semiconductor companies. And you can see that for the most part, these CEOs would seemingly be underpaid compared to the model. And then you can type in other ones like oil and gas, and you can see kind of different situations. So, and you can click on each of these different people and it'll pull up the stock price and so on. So one of the things about the CEOs is that a lot of their compensation is based on performance, whether or not that company is doing well. And one of the measures of performance is the stock price, whether or not the shareholders that are the owners of these public companies are getting paid and getting rewarded for owning that company. So this is a really cool demo that we're going to go through. We're going to be using predictions from Tidymodels and Workflowsets, the two main packages or the ecosystem of packages. It uses web scraping of Google images. So each of these images that you saw in that app, they actually get automatically downloaded from Google. And then data sources. So there's two different data sources, Forbes and Yahoo Finance. And then Shiny, obviously, that's the main technology here that puts the whole analysis together. So why Workflowsets though? So one of the things that I find interesting about Workflowsets is it really helps scale out the ability to tune our models and figure out which models are our best models. So I call it model experimentation and selection. But it's basically this process of hyperparameter tuning and then figuring out which models do the best. So the ingredients that I saw from Workflowsets, it's got some diagnostic tools that really make it very interesting. You can see here that you've got metrics like RMSE, root mean squared error, and you can measure your models with distributions around them based on how they do, how they measure up on the data set. So we can see from this plot, lower is better for RMSE, and the best models are our boosted trees and our SVMs, the blue, the dark blue and the green. The red models are a little bit higher, and that's the linear regression. And that's and R squared's higher is better. So the blue models are giving us the best R squared. Julia, is there anything else that you want to talk about Workflowsets? This is kind of the main attraction. So I want to make sure that I give everyone, the right picture of what all this package does.
Yeah. What I think if you go back to, I think, the Tune package and you look at some of the really early issues that people posted, one of the very earliest issues was people saying, hey, this is great to be able to tune a model, but I want to throw a whole bunch of models in and I want to compare them to each other. I don't just want to tune, say, the hyperparameters for an XGBOOST model. And to be honest, our group had concerns about it, right? It's like, oh gosh, are we gonna just allow people to, are we gonna let people shoot themselves in the foot, right? By not allowing people to have enough thought about the models that they're choosing. But
there is a fine line between automation, making it so easy to use, but then, they don't learn and they don't understand what's going on underneath the hood. And that's kind of the balance that I've always, as an educator, tried to teach people the fundamentals first, and then give them access to the.
Well, I mean, and that's kind of a lot of what Tidymodels is about, is like, we want it to be easy to use, right? We want it to be easy to use, but we want to put appropriate, we want to encourage good statistical practice. We want it to be easy to use, but we want to encourage good statistical practice. So, so it wasn't a super high priority for a long time to get to this place, right? But eventually, we as we talked to more people and thought about it more, we realized, you know what, this is actually a very common use case. You come to a new data set and you don't know, is it going to be, a boosted tree or a support vector machine that is better for this data set? And letting people get to that decision more fluently is a good idea. So let's build the tooling for this, and let's try to encourage good statistical practice in how we build it, how we document it, how we teach it.
Good. And I do have some breaking news too. Now, it's not 100% developed yet, but for our model time series package, we're actually working right now on a Workflowsets integration, because I think it's just so powerful, and it really kind of follows the same philosophy with model time, being able to experiment with a lot of time series models and be able to select the right ones to move on to the next step, and then and finalize your forecasting. So
that'll be so exciting to see.
I'm excited about it. This package is a game changer. I'm telling you guys right now, this package is awesome. It really is. All right, let's jump into the demo. What I want to do, and I'm going to make this, I'm just going to kind of, here, hold on one second. Let me stop my jobs. I've got a bunch of jobs running. So make sure I don't run out of any memory here. Actually, let me just do this. Session, restart R, terminate jobs, start new session. Okay, that way I make sure I'm on a fresh session. So get my Workflowsets back up here. Okay, so for my Learning Labs Pro members, so the structure of this analysis that we're going to be going through today, it's all in this O1 CEO analysis.r file. So if you look at the project over here, there's the CEO analysis.r file. We're going to be working with data that's contained over here, OO data. I've got some stock prices, and I've got some CEO compensation figures, and a few features in here. We'll talk about the data set here in a minute. I also have an O2 bonus code, and this is cool. So I made a script here that's in this file. I'm not showing it to you guys because it's a bonus for becoming an LL Pro member. You'll get it when you sign up. But it's pretty cool. So it's this. When I source this scrape Google image, if I check out my environment, it pulls in this function here. And one of the things that we do in that app that I showed is we need to pull in some images, right? So this little function, we can put birds here, right? So birds, and what this is going to do is going to download into this ZZ Google Scrape, which is just kind of like a play folder. So you can see I've been experimenting with this function, downloading kittens and puppies. So I'm going to download some birds now, and it downloads birds from Google. And this is the image that pops up. So that's the first image. Sometimes you don't always get a great image for your first image, but yeah, if we do tigers, so we'll do an animal theme here. And there, we got an image of a tiger. So it's pulling it straight from Google. That is how I built out the app functionality, because in this www folder, in this image folder, you can see I've got every thumbnail of all 500 CEOs that were analyzed in this analysis. So pretty cool. Check it out. If you want that function to image scrape, that's how you do it. You just join Learning Lab Pro, and it'll be in this O2 scripts folder. And then there's the app.r file. This is the third bonus, and this is a mega bonus because this is our app explorer. So when I click the run app button, I'm going to save selected, and that's what pulls up the Shiny app that kind of packages this analysis that we're going through today. And you can see it's pulled it up right here. as I click on different CEOs, it estimates different predictions for them, predicted pay, and it shows their stock prices and so on, and it uses the thumbnail. Okay, so with that said, let's jump into the analysis. Here, let me go to my jobs, and I just want to stop this job so I can so I'm not consuming resources unnecessarily. All right, the analysis today, this is the CEO analysis. We're focusing on workflow sets. We've got a ton of libraries. So we talked a lot about Tidymodels. We're going to be showcasing those. So I'm hitting Control and Enter. Control and Enter, we've got workflow sets, Fine Tune, which is a new package as well, which actually speeds up hyperparameter tuning. And while I load in some more of these packages, Julia, do you know anything about Fine Tune?
A bit, yeah, a bit.
I know that's one of Max's kind of
babies.
Babies, exactly. Yes. So Fine Tune, from what I understand, it does a little bit of makes it more efficient, right?
Yeah. So it has racing methods for tuning. So if you say you want to tune a model, you can throw a grid. You can be like, okay, I'm going to check all the possible options. Just check them all, see which one is best. You can use Bayesian approaches where you say, okay, check this grid, and then use actually like Bayesian models to decide which ones to check next. And so Fine Tune has these other racing methods, which are where like you use statistics. You test some set, and then you use statistics on that set to decide which ones to test next. So there's a couple of different ways to do the racing to decide like how, and you end up not getting as complete a picture of all the possible hyperparameters that you test, but it ends up being like almost as good and saves you like, you only end up testing like 25% of all the possible hyperparameters, and it's like almost as good.
So this workflow sets, we'll see. It does take like a minute and a half for me to run through, we're building like 90 models, but anyways, it takes like a minute and a half, but versus the grid search approach, it might take like 5 minutes to run through. So it's a real big productivity boost is what I saw. We'll also be doing some parallel processing. I've got a few packages here, some EDA cleaning, time series, finance, my TidyQuant package, and Tidyverse, our core package. So I've gone ahead, I've loaded all of those in, and now I'm ready to get started. I'm going to read in my CEO compensation tibble, and we'll take a quick glimpse at this data set. So this data set was mainly scraped from Forbes back when they did CEOs in 2008. It has their the target here is total 2008 compensation. It's got a few other these four here is your compensation is basically your salary plus your bonus plus other plus any stock gains that you've made, and that's what your CEO compensation is. And then basically what we're going to be doing is analyzing this as a function of everything else except these features, because these four features aggregate to make this feature. But you've got things like performance, like 6-year performance return, performance versus rank, tenure related, and so on. So we've got a pretty solid data set already. But one of the issues that I immediately saw when I started going through this, so I'm using the Data Explorer package, and they've got a nice function here called Profile Missing, is that we're seeing a lot of missing data. And this is why I wanted to use workflow sets, because what I wanted to do was I wanted to determine whether or not it's beneficial to just remove those features or to have different imputation strategies and see which ends up being a little bit better. So that's one of the things, that's one of my rationales. I want to try different recipes out, which normally, we're all accustomed to trying different models, right? But different recipes is also a good use case for workflow sets. So I'm just going to clean up the CEO compensation. I'm going to clean the names, and I'm going to parse out some of the text data. Like this percentage here, I'm going to parse this as a number and so on. So once I clean it up, I've got a data set where it's all either character, if it's actual text, or it's numeric if it's numbers. So that's the first part. I also, in analyzing this problem, one of the things that's very apparent is that CEOs are, their compensation should be based on performance, typically of the company. So stock data is going to be a very important thing. So I have this script here. If I Control-Shift-C, what this does is it actually, for all the tickers that are in the CEO, so if we've got like 500 CEOs, what it does is it goes through, it uses TidyQuant to go through every single ticker and pull it in. It will take about 9 minutes or so to run. So I'm not going to do that right now. Instead, I've went ahead and I've saved it as an RDS file that's located over here in our data. And I'm going to pull it in just by reading the RDS file. And right away, we've got our stock prices. It's got the symbol, a timestamp, and then the other column that we're going to be interested in is this adjusted column. We can take a quick look at just one of these. So I'm going to take a quick look at the Apple, and I'm using the plot time series function from TimeTK, and you can see over here, it's made an interactive chart, very similar to what we showcased in the app. So this is actually, this function is used to make that chart in the app. What I'm going to do is I'm going to do a little bit of data wrangling. So if you like dplyr and if you like the Tidyverse, this is going to be basically a little bit of a clinic here. We've got some raw data. We're going to group on symbol and summarize by time. So what this does is calculates the performance. So we're summarizing each year the total performance, which is going to be just kind of like a percentage return. It's going to take our last minus first, or most recent, our most recent price within that year, minus the first price within that year, and then just kind of divide it by the first adjusted. So that'll give us a percentage return, or at least a rough idea of the percentage return. So if I run this first section here, we can see for every symbol now we've got each year, we have a performance. So think of this like a percentage. A, which I can't remember, I think that might be Alcoa. They went down 16% the first in 2004, 2005, they were up 39%, and so on. Okay, so that's kind of our performance. Now we have to get it into the right format. So we're going to pivot wider. That's what this next section does. And what this does is it gets it into a format where we've now got the performance 2004, 2005, 6, 7, and so on, all the way up through 2008 for all the different stocks. Now you can see we have 361 here. It's not the full data set because there were a few stocks that I believe either no longer have information from Yahoo Finance or something happened. And then the last thing is we're going to calculate some additional aggregated metrics. So basically what we're going to do is we're going to say, okay, what's the median of these 5 prices or percentages? What's the mean? What's the standard deviation? And we're going to use the C across function, which is the trick here. So we're going to use row wise with a mutate, and then C across with the various functions that we want to calculate. So performance mean, we'll do the mean of these columns here. And then performance median, we'll do the median, and so on, standard deviation and sum. So we're going to use those as our engineered features for performance. Once that's done, we now have 10 new columns to add to our data set. And then there's one other thing I wanted to do, and this is kind of a cool thing from my 101 course. If you take that, you'll learn how to do k-means clustering. So the other thing is that some of these companies like Apple, which is a tech company, may have suppliers that are in like a semiconductor space, and they may have similarity to Apple. So what we can do is we can kind of group different stocks into clusters, not just based on their industry, but actually based on how their stocks move. If they move similarly together, they'll be put in the same group. So what I do here is I, again, take my stock prices, and I grab the symbol, date, and adjusted column. So symbol, date, and adjusted. And then I group by symbol. I calculate some daily returns again. And then I do some pivoting. And what this does is it gives me all of the stock returns on a daily frequency in a wide format. So when I say wide format, that's the format that it's not quote unquote tidy, but it's the format that when you do your k-means or correlations and that sort of thing, you need it in this kind of wide format. So each one of these rows, you can see there's 723 rows. Each of those is a timestamp. You can't see the timestamp here because I dropped it, but it gives you kind of the percentage up or down from the previous day. And then what we're going to do is we're going to see which of these are similar based on their stock price movements. So an example of a correlation, we could do that right here. And we can see here that if I look at Oxy, for example, I can see 0.754 is here. So that means that which stock here? To do 754. That's this one, Hess. So Oxy and Hess are very highly correlated. These two have a 0.754 correlation. They should be grouped together. So that's basically what we're going to be doing. We're going to use k-means to do it. And that's what this next part of it does. We're going to come up with a k-means object. And it gives me then a group assignment for each of these. So Google is in group 4. I can see Dow, which is Delta Airlines, is in group 4. Starbucks is in group 3, and so on. So we're now assigning some different companies to groups, and then we're just going to put this into it. We're going to tidy it up. So I'm going to use the endFrame function. And now we have, in a nice tidy format, the symbol and the k-means group. And that can be another feature. Now we've got all of our features in 3 different data sets. So we've got CEO compensation that was scraped from Forbes. We've got stock data that was pooled and performance was analyzed. And then we've got the k-means group assignments. We can combine all 3 of those using this section of code here, just some left joins, and we're going to basically join on the ticker and symbol columns. So when we do that, it pulls in all of our data. We're going to save it as CEO compensation joined. And now you have a nice data set of 27 columns that we can start to mine for information in order to be able to come up with a compensation model. And then you can see here all of the features that we added in. So these are some of the performance features. This is the k-means group assignment. You can see that here there is a lot of missing data. So that is something that we're going to have to handle next. We can also view the missing data. That's what this section of code does here. And you can see some of this has 64%. But the nice thing is those performance features, which are very similar to these features that were scraped, the performance feature has much lower missingness. So 32% from 64. So it's got about twice as much data that is present. So that should help the model in theory if those performance metrics are important. Okay, now we're moving on to modeling, and we're getting closer to workflow sets. First, we got to come up with some recipes. So I'm going to make a base recipe. So total compensation is my target, and we're going to use all of the features. That's what this dot means. And the incoming data that we're going to be developing a recipe off of is this CEO compensation join tibble. We're going to remove some features. We're going to factor the k-means group because this is actually a grouping variable. So it should be a factor or categorical. We're going to remove any zero variance. We're going to normalize all numeric predictors. So like these big values here, like shares owned millions, that's going to get normalized. And then we're going to dummy all of our nominal, which is anything that has categorical, like Oracle, the ticker, excuse me, these are going to be dropped, sorry. But like software and services, this industry is going to get dummied into zeros and ones. And we'll see that here in a second. So I'm going to run these 2 lines here. And while that populates, we can see that this is our base recipe. It has now normalized the data. It has dummied some of these columns here. And we see our k-means group got dummied as well. So now we're getting closer to a feature set that is ready for analysis. So this is where workflow sets comes in handy. We can come up with different recipes. So I want to actually test out recipe with no missing. So I'm going to use this new step select function, which is just brand new in recipes. Am I right, Julia, or am I right?
Step select.
Step select.
Yep. Mm-hmm.
Brand new. Brand new.
Yep.
Okay, and then so that's going to create our first recipe. How step select works is I'm going to select any columns where there is no missing value, or I'm going to deselect those. So that's going to give me a recipe no missing. So when I process that, what it does is it drops any of those columns that have any NA values in. So this is going to be kind of like my my base recipe here now is my no missing. And then I'm going to create an imputation mean recipe. So basically all my predictors, instead of dropping those columns with NA values, I'm going to keep them, but I'm going to fill in the missingness with the average values. So you can see here, there's no missing, but it's filled in with just a simple average. And then I have one other recipe that I'm going to try. I'm going to try a step impute KNN, and I'm going to actually tune the neighbors. Now we can't showcase this one because it has this tune in here, and Workflowsets is actually going to tune that for us, which is really cool. Okay, so we've got 3 different recipes that we're going to be trying out. Just to recap, we've got drop columns, we've got impute mean, and we've got impute KNN. Next, we're going to try out 3 different modeling approaches. So we're going to do a GLMNET, and we're going to tune the penalty and mixture. Then we've got an XGBOOST, which we're going to be tuning the learning rate and the min-n. And then we've got a support vector machine where we're going to tune the cost, RBF sigma, and margin. So those are our 3 different modeling approaches. We need to come up with some resamples. So we're going to do 5-fold cross-validation. So I'm going to run that here. We're going to use the vfold CV function from the rsample package. That's the one that Julia is now maintaining. And then we're ready to move on. Once we've got resamples, model specs, and recipes, we combine them all, and that's where Workflowsets comes in. So this is really cool. We're going to create a workflow set. We're going to list out our preprocessors. So we've got recipe no missing, and this gives it a kind of like an ID or a name. So there's no missing, there's recipe impute missing, and then impute KNN. And then I'm going to have my 3 models in here: GLMNET, XGBOOST, and SVM. So I'm going to call this workflow setup. And when I set cross equal to true, what this is going to do is it's going to cross it. So it's going to give us different combinations of recipe, so no missing, and model, GLMNet, no missing XGBOOST, no missing SVM. So am I right, Julia, in saying that's pretty much how the workflow setup works? And then, so we've got the cross equals true argument. Is there anything else that we need to be aware of when we're setting up a workflow set?
I don't think so. Not for basics. There you can go on, and if like there are other arguments in there if you need to set certain options. But yeah, no, I think that's it. You put your preprocessors in. Preprocessors don't have to be recipes. They can be a formula if you have like a real simple model that just needs a formula input, or even just selectors like
like Tidyverse selectors, or
just like tidy select selectors.
Yes, tidy. That's what I meant. Yep.
Yeah. But yeah, I think that's it.
Cool. All right. Well, we're getting to the meat of it then. We've got a workflow set up. Now, what it's going to do is it's actually going to run, and it's going to fill in this information as it runs. So what I'm doing here is setting up parallel processing. In the interest of time, I think here, let me see if I can run this as a job. I just downloaded this new package called job. Let's see if it works. And yeah, it's not going to work. For some reason, it keeps telling me I had it working at one point. But what's nice is you can run it as a background job, but doesn't seem to be working for me right now. So I'm not going to run this section of code here. This is where we take our workflow setup, and we just pipe it into workflow map. And this is where we're going to do our tune RaceAnova from the fine tune package. And then we just give it our resamples, our grid, and our metric set which is our yardstick metrics of what we want to analyze, like RMSE and R squared. Those are the goals that we have. And you set verbose equals true. And then if you run that, it'll take probably 2 minutes or so. But I already pre-ran it, and then you get your results. And yeah, we get our results for our different modeling approaches. So what's cool is when you have your results, then you can analyze them very easily. So one of the things I like about Workflowsets is they have these auto plot functions, and I'm just going to change up the color scale using scale color TQ. So basically what it does is if I run this, it gives me the auto plot, which shows, and this is the visualization I showed previously, where you can see, which models are doing the best, and I can see boost tree here. And then these other two things are from TidyQuant. It just changes up the themes a little bit, make it kind of blue and reds. This is just a theme I like. That's optional. Then what you can do is, once you see, you've got some models that seem to be kind of all performing pretty well here, your boost tree, your SVM, you can get a little bit more information on them. You can get the actual rankings with this function called rank results. So I'm ranking on the RMSE, and then I'm filtering to RMSE so I don't get duplicates in here. And I can see impute mean XGBOOST is actually doing the best, followed by I guess mean XGBOOST is in here twice. And I'm not 100% sure why it does get put in here twice, but maybe that's just kind of
so it's the same preprocessor and two models. So I think it's there with different tuning parameters.
Oh, different tuning parameters. Okay.
Yeah. So like one set of tuning parameters did better than the other one.
Oh, okay. All right, cool. So that's interesting, because then what I'm going to do is I'm going to take this workflow ID and pass it on. And so maybe we'll have to talk about that to make sure I'm doing it right. But so that's how you find out which ones are doing your best. And you can see that the best no missing is this XGBOOST 24.9. So the mean's getting 24.5. So there's a little bit of an improvement there by keeping some of those features in and doing the imputation. And it's interesting, the KNN in this case didn't do quite as good. It did about the same as the XGBOOST, but the best one was the mean. So what we can then do is use autoplot again, provide it the ID here, and this allows us to visualize the best parameters for that model. And this is a nice chart, especially for learning. You can see that the learning rate is pretty important here as it gets to, and this is on a log base 10 scale. So as the learning rate gets to negative 2.5, which log base 10, that's around 0.03, its performance drastically improves compared to if it's like a 10 to the negative fifth, which is around 1e negative 5. So that's pretty low. Then the performance degrades. So remember, RMSE lower is better. So around 10 to the negative 2.5, it seems to be doing pretty well. So allows you to have some diagnostic tools before you move into that final model. Then once you've decided, okay, I'm ready to move forward, you can take your results. Again, this is just the output of that workflow map function right up here, this workflow map. And then you can pull the workflow set for the impute mean, and you're going to select the best, which is RMSE. So when we do that, what this does is it gives us the parameters of the best model. So min n 21, learn rate 0.065. And then we can finalize the model. So we just take our model, we finalize the workflow with those parameters, and then we refit it to the data. So we run that. And then we have a new model now that's just been refit with those parameters, and we can make predictions with it. And then we can also, this is a visual of the predictions versus the actual values. So this line right here is just at kind of like a 45-degree angle. So anything over here, total compensation is greater than the prediction. and anything between 0 and this blue line is it's less. So you can see that it's kind of seems to be getting like the central tendencies, but there are definitely a few outliers up here, and we'll explore those in more detail in a minute. And then we can also get the variable importance, which is really cool too, because if I switch this up to VIP and run this, we can get a plot really quickly. And then if I leave it as VI, that gives us this importance table, which this only shows the top 10 features, but you can see shared owned millions, performance versus pay rank is very important, total return during tenure, and so on. So we've got kind of some features in here that seem to have some predictive ability. So what we do then is once we have our analysis, we can put it together and we can build an application with it. And basically what this app does is it takes all of the analysis that we just did and packages up in a nice, neat format, so that way people can interact with it. And you can see here what we've done. We've got our prediction that we've made previously. We've got the actual pay, and basically what we're doing is kind of making those predictions using that model, that XGBOOST model that we made, and that's what goes in this column right here, 2008 compensation model. And that's how it works. You've got now an application where you can pull up different people, and it'll kind of showcase, how valuable they are to the company, what their actual pay is, what they're predicted to be paid, and so on. And that is the demo. So if you're interested, I do have a short kind of some tips on learning more. If you want to know more about how to learn what I just did, obviously, if you join Learning Labs Pro, you can get all of the code that you just saw today, and you get the bonuses. So that we have the two bonuses, the one that scrapes the pictures from Google, and the other one, which is the mega bonus, the Shiny app, that packages up our analysis. It's really useful if you learn Shiny to be able to deploy your analyses into production and basically give businesses what they want. Being able to utilize their data more effectively at scale, so people who are non-technical don't have to learn how to code. So just touching on kind of the next steps for you. So my goal is to help you learn no matter where you are in your career. If you are already advanced, I have some things for you. And if you are right here, like I was when I first started, just kind of learning, that's also, I have some things to be able to present to you. So my goal is to help you go from here to here as fast as possible. I want you to be the motocross rider that's doing, backflips in your organization. And I don't want you to be struggling, learning data science and how to apply data science to business. So a couple questions for you. Do you know the Tidyverse, Shiny, and machine learning already? If you do, the program for you is Learning Labs Pro. I'm going to throw that. I'll put that right into the chat. It's a very powerful program, but it's not designed for beginners. So everything that you saw today, it's pretty advanced. We're talking workflow sets. We're talking, all the stuff that's, it's kind of like Julia, what you were saying, Tidymodels, that book is great once you've kind of gone through some of the basics, but if you're still going through the basics, then it might not be for you. That's kind of how Learning Labs Pro is. If you're going through the basics, I have another program for you. But Learning Labs Pro is very cool. We've got a ton planned for 2019 or for 2021. You can see we're well into our Tidymodels extensions here, talking about all sorts of things. But we also have big data coming up. We've got Bayesian. We have more time series, and I've been interjecting some time series stuff into the LL Pro as well. But we have a lot, and we have a lot more applications coming, like HR analytics, marketing analytics, financial analytics, and so on. Okay, so that's Learning Labs Pro. Next, there is, if you're interested in learning in depth, are Tidyverse, Tidymodels, Shiny much deeper, then the program that you're interested in is the R-Track. And that's kind of like the precursor to Learning Labs Pro. So Learning Labs Pro kind of keeps you learning, with new labs every 2 weeks. What the R-Track does is it gets you from 0 to 100 in, months or weeks, not years and years and years. So you're going to be doing business projects. You're going to be building production-ready web applications. It's all in this R track. It takes everything. Everything is taken care of for you. So you don't have to make any decisions. It's just easy. You start it. You take the first course. You complete the first course. You move on to the next. But you're probably thinking to yourself, oh, well, I've already tried different programs, and why is your program different? Well, I have news for you. My program is different, and it is different for two reasons. First one, it gets results. And my proof is that I have successfully transformed many students. They're getting promotions, they're getting new jobs, they're accelerating their career. And there's nothing worse than being kind of stuck in a plateau. And this is what's been helping them get out of that plateau. So this is an example of Jennifer. She landed a VP of Strategic Analytics role at a prominent financial company. She's been following the business science problem framework, and it helped her complete her interview. And she impressed the hiring manager with our markdown report, which she learned in my 101 course. So this one comes from my 201 course. This comes from my 101 course. And she finished a data product for her interview that impressed them so much that they fast-tracked an offer to her. So she's not alone, though. The transformations are happening to all of my students. They are getting new jobs. So you see Masataki, he got a job at a top management consulting firm. Zidu, he's improving patient costs and got promoted. We got Mohana, he got 3 raises in a year. And then we've got others that are really doing successful things with Shiny. So Herb, he deployed his first Shiny app in 3 months. And Raj, he actually won the 2020 Rstudio Shiny competition. So he's one of my students too. So, it doesn't matter where you are in your career, you're going to be able to move faster and accelerate your career with a program like mine. And then the second reason that it's different, it's streamlined. So you don't have to make all the choices that you do with other programs. It just takes care of everything for you. So this is the way it works. There's 5 courses in the system. The first course, what it does is it teaches you your foundations in the Tidyverse, and it teaches you everything from cleaning to visualization to data science algorithms to business reporting. It takes about 8 weeks to complete. You get that knocked out, and then you're really good with the Tidyverse. Then you can move on to analytics, or you can actually move on to the web applications. We'll talk about 2 different tracks that I have that are kind of sub-tracks, depending on what your specialization is. But if you want to learn it all, this is very powerful. You can do advanced machine learning, then time series, then web applications. And there's a web applications level 1, which teaches you predictive dashboards. And then level 2, which teaches you like AWS and Bootstrap and all of the things to make really powerful Shiny applications. So those are the 2 different tracks. I'm going to put some links in the chat right now, and I want to give everyone 15% off today. So you just need to use that promotional code Learning Labs Pro, and I'm putting those in. So we've got the 5-course R track, which is perfect for the beginner who wants to go from 0 to expert as fast as possible. We also have a 3-course bundle, which, as you can see in the R track, so that gets you, if you do the 5-course, that's everything from 0 to hero. But some people don't want to learn Shiny apps, and that's okay, because I have a track now for that too. And that's what the second one does, which is the data science bundle for people who just want to learn the Tidyverse, machine learning, and time series. And then there's also, conversely, on the flip side, some people don't want to learn all the machine learning and stuff. They want to jump right into web apps. So we have a 3-course bundle on that as well. That you learn the Tidyverse, you skip some of this stuff here, and then you go right into Shiny apps and AWS and those sorts of things. So we've got 3 different tracks depending on who you are, what you want, and where you want to go. I just put the 3 links into the chat, 15% off today. Again, those are great for beginners. And if you're already intermediate or expert, check out Learning Labs Pro. All right, I am done. that is a mouthful. I'm ready to handle some questions. Julia has been gracious enough to stick around. So what I would love to do is just field some of your questions, if you guys are okay with that. I see 8 questions in the Q&A. And if you guys don't mind, I'll just kind of go down through. As a data scientist, in what case have I used, do I have to use R? In what case should I use Python? This is from Kadir. Julia, do you have any thoughts on R and Python and which ones you should use for what?
Yeah, well, so I mean, I think the ultimate answer to that question is that like you should use the right tool that you're most productive in. Like that's the real answer, right? I think that beyond that, I mean, I think like some of the things I turn to Python for are, I think I see this on some of your slides. Like, I think like Spacey is like an amazing tool in natural language processing. Although for a long time when I'd use it, I'd like make a little Python chunk in my R Markdown and then like do, tokenization or like something with Spacey in a Python chunk and then like pass it down to continue to do some of my other things using R. What else have I like turned to Python for?
What about reticulate too? I mean, that's something that I think is a newer technology that a lot of people don't even know about, where you can use both languages together.
Right. Yeah. Yep. And then some of the things like Keras, like turning to Keras for modeling. Like these are some of the things that I turn to Python for. I mean, I think most in the real world, most teams are bilingual, so it's really great to be able to read Python code, even if you're not like mainly a Python person. I mean, I think I probably already showed my hand that like the Pythonic way is like not one that like super clicks with me in the way I like to write code or organize my projects or anything. So, but those are some of the things that I've turned to Python for.
So I will say this, I am getting a little bit better at Python. And the thing that I'm seeing that Python's really good for is it's super easy to build a package in Python. And it sounds kind of weird, and I don't know why they don't teach it a lot to data scientists, because I see people on Kaggle and everything kind of coding everything from scratch. But you can make a Python package so simply, and I wish R did that a little bit better. But I will say this, Python, I think people kind of overvalue it in certain circumstances because there just aren't, the ecosystem isn't as, it's not as wide. There's not enough diversity that I see yet in the packages that are in that ecosystem. So you have to, what it forces you to do is actually write a lot of your own code in order to do it. Like if an example might be, for time series, I have time TK. They don't have time TK. They have some pandas tools like resampling and that sort of thing. That's great. But when it gets into like doing advanced time series machine learning and modeling, they don't have the model time and time TK yet. So that's kind of that automatically pushes me to R. But again, what Julia said was really really profound. Do what you're comfortable with. If you like coding in Python, code in Python. There's nothing wrong with it. And if it takes you a little bit longer, who cares? That's not a big deal. But there's definitely certain advantages to learning R. To me, Tidyverse, hands down, that's one of the best systems out there for quickly analyzing. Visualization, Python is not very good in visualization. I will tell you that. ggplot2 is the best package out there for static, and it has a nice handy function called ggplotly that converts ggplots to interactive plots. So it wins that one. R Markdown, hands down, it's better than Jupyter. Jupyter struggles creating PDFs that are professional quality. R Markdown, it's simple. It really is. So that's kind of how I divvy up my work. I'm definitely a fan of R and making, my reports very easily. It just makes things easy for me. But Python, from the automation and from some of the ability to build your own software, it's got a leg up there. So, okay. Are you using the DT package? And this is from Diab. I hope I'm pronouncing your name correctly. Yes, I was. Anonymous attendee. Can workflow sets currently be used in conjunction with model time? It can, but you have to put a little extra code then, and we want to make that transition very seamlessly to go from a workflow set to selecting the workflows to converting those into a model timetable so you can then do things like ensemble them and visualize the forecast together. So we're working on that integration right now. Simon, Julia, could you expand a little about your feeling about the differences between R and Python? Object-oriented approach didn't mesh with your mindset. I've hidden from Python like a wimp. It's okay, Simon. A lot of us have. So it would be great if I can keep avoiding it, but if give a good reason.
Okay, so R came out of S. You've probably heard this, and so it came from it was very influenced by Lisp. And it so it comes from a very functional programming kind of, it's not a pure functional programming language, no, but it has that influence. And especially if you're a Tidyverse person, and especially if you use purrr and that kind of thing, then you are kind of in that sort of tradition or river, of what programming is like. Most people who write in Python, if you've done all the things with getters and setters and new, that kind of thing, that's all object-oriented kind of programming. And my opinion is that it's not as good for data analysis. It's not as good for modeling typically. And it's not as good a fit in my opinion. I don't know. So, or it does not fit the way my brain approaches those problems as well. And thus I am not as effective in it.
It again goes back to, whatever you're most comfortable with. If you're comfortable with R, use R, but if you're comfortable with Python and you're interested in experimenting with it, and potentially even, it's not a one versus the other. You can always use both. We've got Reticulate now too, that brings everything together. So, as these technologies kind of grow, you can leverage the strengths of both. But the key is, I think, learning the strengths and actually doing some experimentation with both packages and finding out where your struggles are and where you're, and which to use and which scenarios for yourself.
There was another question kind of related to this from Matt over in the chat about, he says he uses Tidymodels model time for model development, and then, but his company is predominantly Python based. What options does he have for experimenting development in R and then deploying in Python? One option I think to talk to the people you work with is how are models being deployed right now? And is there a way for you to do that with your model developed in R? Is the model going into a Docker container? You can do that. You can put your model in a Docker container. Is the model being deployed as an API? You can do that. You can build an API. If they're willing to support you a little bit on the IT side, you can do it. Almost certainly. You can do whatever they're doing in Python, you can do in R. So just have that conversation about how is the model actually being deployed. Probably you can do it in R, whatever they're doing. Whatever deployment story is happening in Python, you can probably do with your model that is developed in R. Anyway.
APIs are a game changer as well. So a lot of companies and many data scientists don't ever learn APIs in their at least not in the beginning. But an API is an application programming, what is it? API. I can't remember. Julie, do you remember what it stands for? Sorry.
Application programming interface.
There we go. Yes. Thank you. But basically it's a way to communicate to, some code that's running on a server somewhere. So if you give it an input, say some data, and you want to get a prediction from it, some output, it'll do that for you. And then that way you can connect up things like Excel or Tableau or, some of these other tools that are kind of more, business intelligence-y. And that's kind of the general use case that I see. Is there, what are your thoughts on that, Julia? Is that what you think?
Can you restate that again? I just saw Matt respond again, so I was reading it. Sorry.
Oh, I'm sorry. So basically I was just saying an API is kind of what like a lot of organizations seem to be experimenting with or transitioning to.
Yeah. Well, and it has a lot of benefits, right? Because then you can have whatever service is over here, not like it can be on its own machine and not have to and whatever needs to be installed over here can be installed over here, and then your other thing can get its predictions or whatever it needs to. Matt responded, I think, says like yes, he knows this, but like he's experiencing this like
friction. Organizational friction is, every organization has differing degrees. Sometimes your options are limited. If they just don't want to budge, then you need to try and figure out a way to kind of give them what they want. If they want Excel files, give them Excel files. If they want Python, just give them Python. But at the end of the day, if they're willing to kind of open their eye, open up a little bit, and if they care about productivity,
that's the thing. I have to hop off actually, but the one last thing I was maybe going to say here to this particular question is like Matt says, you need to be writing this for maintainability, and and if people are, of course you need to be like a good colleague to the people you work with, but like a thing to bring up is this issue of like productivity, is this issue of like what do you want to pay me money to do, to be more productive, to be able to get more done, or to struggle, and to like, what is it worth you as an organization to pay me to do,
Yeah. And some things are impossible too. So there may not be a solution to what they ask for.
Yeah.
So
you may have more questions to answer, but I just want to say thank you all so much for coming and answering me and asking such great questions and listening. It's been such a pleasure to be with you all. I do have to hop off. Thank you so much.
Thank you so much, Julia. I'll stick around to handle a few more, but really, thank you so much. It was invaluable having you on today. Thank you.
Thank you so much.
Okay, we do have a few more. Can I give you a copy of the chat Q&A? I'm going to send out an email tomorrow-ish, I hope, if not Friday, with the recording. And for those who want to join LL Pro, I will include a link to the chat and Q&A. Walter asks, just curious, some more details on making Tidymodels integrate closer with distributed data storage. So there is a little bit of that going on. I know in Model Time we have a GitHub. What we are planning on looking at Spark as a backend to to Model Time, and there's also already a little bit of that stuff going on, I think, on the Tidymodels end. I don't know how much they've developed that quite yet, just because I haven't really explored it too much yet. But we do have long-term objectives to make that happen. Carl asks, one more question about Learning Labs Pro. Do you have enterprise versions? So yes, we actually have some enterprise versions. We have team plans. What I would suggest is shoot me an email, and we can kind of discuss those team plan options. There are some volume discounts and that sort of thing that we're beginning to offer, and we will have some more announcements on that down the road, but it's actually available now. We have several companies that are purchasing team plans. Okay, Oswaldo, Matt, when you say a course is complete in 8 weeks, how many hours per week? So I expect about 5 hours of effort per week per course, and that'll get it done in about 8 weeks. Now, some weeks may be more intense than others, some less, but generally speaking, that's how it goes. Okay, let's see. Oh, Jean Paul says he's an LO Pro member and he loves it. Oh, thank you. Thank you so much. All right. I think that's it for questions. I'm going to let everyone go, but thank you so much for attending today. And we have more exciting content coming. I've got a lot of new Learning Lab content on, I think next is going to be targets for production and doing some automations. So it'll be really cool. All right. I will see you guys in 2 weeks. Until then, have an awesome time. See ya.